Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College. The topic that I am going to discuss today is Relational Calculus, which is covered under the subject Database Management System. The subject code is BMC 204 and the students for which we are taking this concept is MCA first year, second semester students. If we talk about the relational query languages, we have already discussed that we have multiple languages like the DDL, data definition language, data DML, that is data manipulation language. Then we have the TCL command, TCL, that is the transaction control language. Similarly, when we talk about the relational data model, we have the relational query languages in which we talk about the relational algebra and the relational calculus. So, relational algebra we have already discussed in our previous lectures. Today, we will be discussing about the relational calculus. When we talk about the relational calculus, we talk about two types of calculus, that are the tuple relational calculus and the domain relational calculus. So, when we talk about the tuple relational calculus, as the name suggests, tuple here means we are talking about the rows. So, when we are trying to fetch the data keeping the rows in focus, that relational calculus is the tuple relational calculus. When we fetch the data keeping the columns in mind or in the focus, in that case the topic that we have is the domain relational calculus, which talks about the columns. So, fetching of the data depends, or the fetching of the data determines which calculus is to be used. If our main focus is the calculation based on the number of rows, then we will use the tuple relational calculus. And if we want to fetch the data on the basis of the columns, then that will be done through the domain relational calculus. So, starting with the tuple relational calculus, it is based on specifying the number of the tuple variables, because our main focus is on the tuples or the rows or the records. So, each tuple variable, it usually ranges over a particular database relation, meaning that a variable may take as its value any individual as its value from any individual of the individual tuple from the relation. So, we have a syntax as we have a relation or a tuple variable T on which we are applying a condition. Now, this condition is a conditional expression which involves a T, that is the tuple variable, and this T is in a relation R. We identify all those T's with or all those tuple variables with the key with a letter or a variable as T normally, but you can use any variable of your choice. So, let's take an example. The first example that we have is we need to find all those employees whose salary is above 10,000. So, in that case, we have, suppose, the table or the relation as employee. For this employee, because we are fetching a tuple, we have created a tuple variable as T. As per the syntax, we will be writing with the curly braces T with a hash, and then in the condition, we will have the table name, that is the employee with the tuple variable, and the condition that we need to provide, that is the salary is above 10,000. Now, this salary is basically the attribute of the table employee. So, we will be saying that T dot salary, just to denote that we are working with the salary column, salary attribute of the table employee. So, this is the way we write a particular expression. This is the conditional expression which involves T, and this is the relation name along with the tuple variable, and this denotes that this tuple variable is existing in the table employee. We will have further examples, like we have the next example as find out the date of birth and address of the employee whose name is Mahesh B. Kumar. Now, we need to identify the date of birth and address. If we look at the first query or the first question says we need to find all the employees. That means we need to identify the details of all the employees, all the details of all the employees. So we did not mention any specific column in this particular example. But in the second example, they are specifically asking us to find out only the date of birth and address of the employee. So in order to identify only the date of birth and the address, we'll be writing, we created from the employee table, we created a tuple variable t. Now this t will be fetching only the date of birth and address. So we'll have t dot date of birth, t dot address of the employee. So we have employee t the way we have done over here. And now we have the condition as where the name is Mahesh B. Kumar. It may be a possibility that we have three separate columns for one column for the first name, then the middle name and the last name. So employee t, and where we have the first name as Mahesh, the t dot middle name as B and t dot last name as Kumar. So this question or this will identify only the date of birth and address, only the date of birth and address of the employees from the employee relation with the tuple variable t under the condition where the first name is Mahesh, the middle name is B and the last name is Kumar. So this is how we write the queries under or the questions under, we solve the questions under the tuple relational calculus. Now, we have certain information that need to be specified. For each tuple variable t, the range relation is R of t, like we write, no? Employee with t. The condition to select particular combination of tuples and the set of attributes that are to be retrieved, like we have seen over here. These are the set of attributes. Then the condition that we already have these conditions and the tuple variable for which we are finding out the data. So if we are talking about the expression for the tuple relational calculus, as we have just seen, we have t1 dot a1, that is attribute 1, attribute 2, attribute 3 till attribute m. Then we have multiple conditions along with the relation. So when we talk about the formula or a condition, it is made up of one or more atoms that are connected with a logical expression and or not, and it is recursively defined as follows. Every atom is a formula, like we have seen over here. What is an atom basically? An atom is a single form of the relation where R is a relation and T is a tuple variable. So it identifies the range of the tuple variable as the relation whose name is R. So when we talk about the atom, every atom is a formula. If we look over here, we have these as an atom. So this atom is a formula. This atom is another formula. This atom is another formula. Each and every atom is a formula. And if we have two atoms together, if F1 and F2 are two formulas, then we can have either F1 and F2, like we had over here, the first name and the middle name. We can have the F1 or F2 or not of F1 or not of F2. And we know the truth values. When we say that F1 and F2, in that case, F1 and F2 is true only when F1 and F2 both are true. In case any one of them is false, in that case, we'll get the result as false. In case of F1 or F2, if at least one of them is true, we get the result as true. If both of them are false, we'll get the result as false. Not of F1 is true if F1 is false. It is the complement. If F1 is true, not of F1 would be false. Similarly, if F2 is true, not of F2 would be false, or F2 is false, in that case, not of F2 will be true. Now we have the universal and the existential quantifiers. Existential quantifiers are denoted with the there exists sign, and the universal quantifiers are denoted with the for all sign like this. Now, existential quantifier is where we say that some of the things exist which which follow a particular condition, and out of the whole of the set we have some of the records which follow a particular condition or which makes the condition as true, and some of the records are there which does not make or which does not satisfy a particular condition. But when we talk about for all, in that case every tuple in that particular relation is true, is considered true. So the symbol there exists, this is there exists, is called the existential quantifier because the formula f, that is there exists t of f, is true if there exists some tuples in the relation that makes this f formula as true. The symbol for all is called a universal quantifier because every tuple in the universe of those tuples make f true to make the quantifier formula as true. In that case, we cannot have any of the tuple which does not satisfy this condition when we are talking about the universal quantifiers. Then we have free and bound tuple variables. The tuple variable t is bounded if it is quantified, meaning that it appears either in there exist or for all clause. Otherwise, it is free. Free means we are not applying any of the condition over there. If we are applying a condition either by there exists or a universal quantifier, in that case it becomes a bounded tuple. So we can define a tuple variable in a formula as a free or a bounded according to the following rules. The first one, an occurrence of a tuple variable in a formula f, that is an atom is free in f, we do not apply any of the condition. An occurrence of a tuple variable t is free or bounded in a formula made up of logical connections like f1 and f2 or f1 or using and or not, depending upon whether it is free or bounded in either f1 or f2. So if we talk about the formula with and or not, t may be free in f1 but bounded in f2, or it would be vice versa. It is not necessary that both of them are to be free or bounded. In case one occurrence of t is bounded, the other one is free, then also we can apply these formulas. So all the free occurrences of a tuple variable t are bounded in other formula f dash of the form like there exists t with f or for all t with f. So in that case, we have three different relations. One relation could be a free relation where we do not have any of the quantifiers. One relation could be with the there exist, and one could be with for all. So all those relations with there exist or for all will be the bounded relations. So let's take the example. Suppose we have the relational database schema. We have all these relational database schemas. Now the first one is to retrieve the name and address of all the employees who work for the research department. Now because we need to retrieve the name and address, the name would be the first name and the last name, and address from the employee table. So we have created a tuple variable t for the employee table, and we have fetched t dot first name, last name and address from the employee table. Now they are asking for the research department. Now because we are working on the research department, in that case we would be requiring this table department also. So we'll be taking there exists a tuple variable d from the department table where is represented as and over here, where d dot d name is research and these two needs to be equal. This DNO and this DNO are to be equal. So we have two conditions from the department table. The first one is the research, the department name should be research, and because we are fetching the data from two tables, we already discussed the foreign key concept. So we'll be taking the department dot DNO, that is d dot DNO, and employee is represented with t. D dot DNO is equal to t dot DNO. Next, for every project located in Chennai, we need to list the project number, the controlling department number, and the department manager's last name, date of birth and address. So project number, because we are working on the project number, we'll be taking the project table in this case. So project table is denoted with P. So we have P dot PNO. Then the controlling department number, the department number is also available over here. So we'll have p.dno. Then the department manager's last name. Department manager's last name would be from the employee table. So we have created an instance of the tuple variable m. So we have m dot first name and last name, the date of birth and address of all those managers. So we'll be taking there exist on the department with D, where we are working with project. So project, location of project is Chennai. So p.p location is Chennai, and because we are working with multiple tables, we need to use the concept of foreign key. So we'll have p.dno is equal to d.dno for these two. p.dno is equal to, p.dno is equal to d.dno, and also we need to find out the manager numbers, because every employee cannot be a manager, but every manager is an employee. So we have manager number from the department. This manager number, if it is equal to the employee number, in that case, that person would be the manager. The next one is we have these tables. The next one is to find the name of each employee who works on some project that is controlled by department number 5. Now, the name of each employee, again the first name and the last name from the employee table, and who works on some project which is controlled by department number 5. So we have two tables, that are the project table and the works on table. The department number is 5. So on the project table, we'll be taking the department number 5, and again we'll be combining or we'll be joining using the foreign key concept with w.eno, that is the employee number and the works on employee number should be same. Similarly, the project and the works on are to be related with each other. So we have x.pno, that is a project number, which is equal to w.pno. The next one that we have is to find the names of the employees who have no dependents. Now, when we are working on no dependents, in that case, we are working on the negation part. Names of the employees, again the first name and the last name from the employee table, and where we do not have any dependents, so we'll have not of dependent D, or we say we do not have these employees as equal. With this, we have this for all, because we say that when we are working on OR and we are identifying this for all, in that case, we'll be working either with the people who do not have any dependents, or we'll be working where the employees and the dependents do not have any relation with each other. There may be some of the employees who do not have any dependents. So all those employees who do not have any dependents will not be lying in this. So those employees will be shown with this not, or will be taking the data from all those employees who do not have dependent and exist in the employee table. The next one that we have is Domain Relational Calculus. Now it only differs in the type of variables that are used in the formula. Here we are talking about the columns, and there we were talking about the tuples. So when we are talking about the columns or the attributes, the expression becomes the x1, x2 till xn, where we have the condition on the attribute variables. There we had the domain variables. There we had the tuple variables. Here we have the domain variables. So the expression over here is again made up of atoms. The atom of a formula are slightly different. An atom of the form relation with the variables are the name of the relation of the degree j, because here we are talking about the number of columns or the domain. The atom of the form xi or with operation on xj, where op is a comparison operator with the operators like equal to, less than equal to, greater than equal to, not equal to, and xi and xj are the domain variables. We can also have it with a constant value where C is a constant value and we apply the comparison operator with the constant value. So we'll be taking the same example. Now we'll be finding out the data, or we'll be solving each and every query that we have done previously with the domain relation calculus. So when we have all of them written as same, but over here what we have done, we have given the variable names to each and every column for easy reference, because we don't have to write it again and again. So the first one is to find out the date of birth and address of the employees. Now to find out the date of birth and address, date of birth is with U and address is V. So we'll be writing the two variables as U and V. Whose name is Mahesh B. Kumar, because we need to find out the name as Mahesh B. Kumar. The first name would be, the first name is Q. Q is Mahesh, R is the middle name, and S is the last name, that is Kumar. We are working on the employee table and we will be having the set of the attributes, all the attributes. So the set of attributes would be Q, R, S, T, U, V. All those are written over here. W, X and Y. So all those attributes are written over here. We'll be calculating on their existing quantifier, except these two will be writing all of them and in their exist over here. It is not mandatory. The mandatory parts are whatever conditions we are applying over here on Q, R and S, they need to be written over here. These all are exceptional to write. You can even omit them. Continuing with the second example that will help us to understand it better. We need to retrieve the name and address of all the employees who work for the research department. So we need the name and address. Again, the name is the first name, the middle name and the last name. So we have Q, R and S along with the address, that is V. So we have Q, R, S and V of all the employees who work for the research department. So we need the department table and the employee relation. The employee relation columns with the department relational columns with AND operator. And the department is research, so I is equal to research and M is equal to Y, that is the DNOs are to be equal. So this Y should be equal to this D number, M equals to Y. So in that case, this M, Y and L should be written over here, the rest can be omitted. The next we have again the same tables. The third one is for every project located in Chennai, list the project number and controlling department number, the department manager's last name and date of birth and address. So we'll be finding out the project number. So the project number is located with, the project number is I. The controlling department number, the department number is K. The department manager's last name, the last name would be S. Then date of birth, that is U, and address, so that is V. All these are taken over here. Now because we are working on two tables, the project and the employee, so we'll have the project and the employee table here. We also need the department because we are calculating the department numbers, the manager's last name, because we need the manager. So we'll be needing this manager number from the department table. So we'll be using the department table also. So it says that in that case, we need to have the project that is located in Chennai. The project location is in Chennai. J is Chennai. So we have J equals to Chennai and the rest of the things for joining. So we have dnum is equal to, that is K is equal to M with this table. And manager number should be equal to the employee number. So N equals to T. And all these K, M, N and T are and J are to be there. But because K is already displayed over here, so we may omit it from here. The last one, find the names of the employees who do not have any dependents. So the names of the employees again with the first name and last name, the first name and the last name, Q and S, first name and the last name. no dependents. So in this case, we are taking not on there exist with dependents, and we say we combine these two tables with t equals to a. Now here is a difference. Like if we look into the previous one, in the previous table we have seen that here we had for all with not of dependent over here. We know that negation of for all is always there exist. So when I say the negation of for all on or, we always get there exist with and. So this with not of there exist over here. So you can either write it with not with there exist, or you can use for all and apply the not on both the both the conditions separately. So here we have taken not with there exist and we have used the and operator over here. We can also use for all and apply not on this as well as on this with the or operator. So that's all for today. Thank you.